In this video, we're going to look at the definition of vapor quality and then compare mass fraction versus volume fraction of vapor. The example we'll use will be steam because we have data to make it easy to make that comparison. So quality is the mass percentage that is vapor. And so a quality of 1 means it's saturated vapor. A quality of 0 means it's saturated liquid. We have to be at saturation conditions when we're talking about quality because we're talking about both vapor and liquid being in equilibrium. So let's consider steam exiting a turbine at 2 bar and it has a quality of 0.9. So what that means is there's 0.9 kilograms of vapor for every 0.1 kilograms of liquid. And since it's at saturation conditions, that means from the steam tables, we're at 120 degrees C to 3 significant figures. That's the saturation temperature. So on a mass basis, 90% of the steam is vapor. The question is, what's the percentage on a volume basis? And so what we're going to do is look up from the steam tables the specific volumes of the liquid and the vapor at 2 bar and 120 degrees. So these are specific volumes for liquid, capital L, vapor, capital V, and these are just from steam tables. So then we can say if we had a kilogram that had a quality of 0.9, then how much liquid and how much vapor volume do we have? So the volume of the liquid that we'd have, so this is now just the total volume of the liquid. It's 1/10 of a kilogram of liquid. Specific volume is this many cubic meters per kilogram. So we have 1.06 times 10 to the minus 4 cubic meters of liquid. And likewise for vapor, we can do the same calculation where we're using now the value for the vapor volume. So for steam with a quality of 0.9, here's the volume of the liquid. Here's the volume of the vapor. Here's the total volume. So if I wanted the volume fraction that is liquid, that's going to be the volume of the liquid over the total volume. So I've calculated then the volume fraction, and I've also calculated the volume percent. So 0.01% the volume is liquid. This is the volume fraction that's liquid. Now the volume percent that's liquid, which means the volume percent that is vapor is 99.99% essentially. So quite a bit of difference. We compare mass fraction versus volume fraction. Indeed, let's just do the calculation from one other condition, the same type calculation, a quality of now 0.1. So 10% is vapor, 90% is liquid on a mass basis. And let's look at the volume percent. It's exact same type calculation. So here's the exact same calculation for quality of 0.1. Calculate the volume of the liquid, volume of the vapor, added to get the total volume, and then I've calculated a volume percent of liquid. So volume of liquid divided by the total volume times 100. Even when it's 90% liquid, the volume percent liquid is only 1%. It's still 98.9% vapor by volume. The final thing then to mention about quality is we calculate the volume from quality by using the volume of the vapor, the total volume, and volume of the liquid. So the fraction that is vapor, 1 minus Q, is the fraction that is liquid. And we can do the same thing for enthalpy, where we're using values from the steam tables for specific enthalpies, cubic meters per kilogram. Same thing for entropy and any of the other state variables.